Hi guys, we're back. Me and Mrs. Milna and Commander Lane over here.
That's right.
From NASA. We're going to talk today about moon phases. You guys just did your season's activity a couple days ago. We're recording these on the same day, hence the same outfits. Mr. Lane looks different. But so today we're going to look at moon phases, and in this activity we're going to pretend we're on a different planet. So you and your fellow astronauts have been sent to an interstellar mission, and I'm just reading the introduction off your sheet, to explore a neighboring star system. One of your tasks is to survey the moon of an Earth-like planet that orbits the star. Each night at the same time, you'll observe the moon and record what it looks like. You will use these observations to determine how the moon changes over time and why this happens. So you need a prediction first, or a hypothesis. So you're going to predict how you think the view of the moon will change as it moves around the planet. Explain what you think causes these changes. So think back, if you guys remember anything about moon phases from elementary school, what causes the phases of the moon. Okay, try your best. And then when you're ready, we're going to go over the procedure. In this one, I really want you guys to try and do this with us. So see if you can find a ball of some sort.
Any round object.
Any round object.
We're going to use the moon pop for us, but for you guys, any round object will work that you can hold out in front of you. So don't make it too heavy or big. Any regular
baseball,
baseball,
tennis ball will work. Apple, if you have nothing else, an apple will work.
Orange, most fruits.
Yep. So any of that stuff, just find something that's round. Try and find a lamp. If you can take the shade off of it, that would be helpful. Or if you have like a desk lamp that has that arm that you can just like pull up. Yep. So you have just a light source that has kind of an empty bulb or a straight bulb. Yep. Because you're not really gonna need you just need to stay in one spot. So you just need one area of the light source. Okay. All right. So do the hypothesis, and when you're done, we are going to start the procedure. Okay. Pause this video. All right, guys. Let's go over the procedure. So the way this works is you're going to stand with your back to the illuminated lamp.
And you got to kind of hold the ball up over your head so the ball isn't in your shadow. So if you you may have to kind of hold the object if you're holding the object in your hand, you got to kind of hold it up over your head, kind of like Simba, and get it up there. And the key is that we're going to observe how the moon changes from our point of view. So in this model, you are the planet. You're standing on the planet, looking up at the moon in the sky, and you want to see.
What do you see? Because think about it. When we look at the moon every night, we're standing on Earth. So we're standing on Earth, and we're looking at the moon in front of us. So it's our perspective of what we see. Okay? Yep. So in the same sense, your eyeballs are you on the planet, which is your body.
Yeah.
Okay?
So what you see here goes in the day one observation section.
Yep, which is 0 degrees.
You want to inwards. You want to go over that. And then for a sketch, if you're in Google Drawing or in the doc, you can add a drawing if you'd like to, and just kind of draw a circle and use the shapes tools to as best you can show what it looks like.
Yep. And if you're using Google Draw, the way I always tell my kids is light equals bright. So what you leave white is what is illuminated. What you shade in gray is going to be what is shaded. Okay, what is being masked. Okay, and we know that parts of the moon, when we watch the moon phases every day, we don't see all the parts of it all the time. Okay, so when you're using Google Draw, you want to make sure that you're using the shapes, and then whatever is white is what is illuminated, and then what is shaded is what is in shadow.
Yep.
Okay. All right. So that's day one.
Yep.
Then it says you're going to observe the moon, record your description, which we just talked about. Once everyone on your team, which unfortunately with remote learning, you are a team of one right now.
But that means you are the best player on your team.
You are the best player. You guys are.
MVP.
Okay. So once you want to rotate 45 degrees to your left. So find your left.
So this is your left, and the best way to find 45 degrees is that it's halfway between 0 and 90. So right in front of me is 0, and then 90 is my direct left. So kind of halfway in between those two, like this, is 45. So I'm going to kind of spin my body now. So now I'm facing the moon again, but I'm facing it at this new angle at 45 degrees.
So this will be, you're going to look at what you see for the moon, and then you're going to draw your observations and then make your sketch. So again, in this case, what is lit up by your lamp and what is possibly in shadow and how much of it is in shadow, okay? And then you're going to draw your sketch in there. Then you're going to go another 45 degrees or at the 90-degree mark, if you're looking at a circle.
So same deal again, go to your direct left and then turn 45 degrees. So now you're kind of right left from where you were when you started.
Yep. So now you're going to, again, do your observation, make your sketch. You're going to continue to do that. So do another 45. Right? And that would be day 4. Right? Day 4? Yes. Yep, day 4.
Yeah.
1, 2, 3, yep, 4. This would be, day 5. Yep,
day 4.
Yep, day 4, and then you're going to go again.
So
day 5.
So day 5 is 180 degrees. So this should be exactly opposite of where you started.
Yep. So you should be now completely on the other straight line.
Yep, kind of facing the sun.
Facing the sun. So now you're going to go another 45 degrees for day 6. Again, take your observation, and at any point while we go through these together, just pause, do your observation, and continue. Okay, or you can watch it all at once, and then kind of follow our lead. Okay, do another 45 degrees.
So now you're kind of
you're at the 270.
Yep, facing right from where you were at the start.
And we're almost, and then you're going to do another 45 degrees. You're at day 8, which is 315, and then you're going to do it back to 45 degrees, and you're back to where you started, which is 180 degrees or 360 degrees, or back at 0 where you started. Okay, so you've done one orbital period. Okay, which is the time it takes for the moon to go around.
My goodness.
The planet. Yep.
Ooh, that's an arm workout right there. Arm workout. Check it out.
So that's one orbital period. That was 9 days on our imaginary planet. Think of how long it takes the moon to go around Earth. Okay, and how are they different? Okay.
Yes.
So.
Think about
keep that in the back of your mind because it's going to be a question later. Okay.
Think about how long it takes for us to go from one full moon to the next. That's one cycle, and here we just did one cycle.
And we said it was 9. They said it was 9
days on this fictional planet.
Okay. So it is one of your data analysis questions. So just keep that in the back of your mind. We want to make sure you guys hit that one. Okay.
Yep.
Once you're done doing your observations and your sketches, you have some data analysis questions and some concluding questions to work on. Again, always, if you have questions, reach out to us via email or custom comments if you want to. But email probably is the best way. Definitely during the school day from 9 to 3. And you'll definitely get a response after 3. It's hit or miss. Okay? We miss you guys. Hope you're staying safe and staying healthy. Okay? See you soon. Bye.